In order to help you guys prepare for exam 3, based on some of the comments that were left on the discussion board, I decided to go back through some of the old material and use that as a way to kind of illustrate some problems that you might see and to kind of help clarify some concepts. So the first one we're going to look at, this was hypothesis testing in the news, part 2. And some people said they were having problems identifying what the null and what the alternative was, especially in context of news articles. So always, the first thing you want to do is go ahead and just read through the article to begin with. I mean, usually I only give you a short snippet of an article, so it won't take that long. So this particular article is about an HIV vaccine trial, and the results of the trial were significant. So what you want to do is you read through the article and then ask yourself, if you were a scientist, what would you have been asking in this study? And in this case, you would have, if you were the scientist, you would have wanted to know, hey, I have this vaccine. Does this vaccine work for HIV? And almost in any medical trial, it's going to be something similar to that. And the reason is, if a company is putting a lot of money in to develop a vaccine or develop a drug, well, they're not going to do that if they don't think that it works. So that's pretty much what they're always going to find out is, does this thing work? We think it works. Does it work? So with that being said, researchers and scientists, they've got this vaccine. They want to know if the vaccine works. Now, almost always, the alternative is going to be what they want to see. And it's usually easiest to start with the alternative hypothesis. So in this case, the alternative, which we call HA, is going to be that the vaccine works. Now, the null is going to be what I call the negative of that, or just the exact opposite. Because you want to remember that the null and the alternative are a dichotomous decision. You either have to be one or the other. Either the vaccine works or the vaccine does not work. So in this case, the null, which is HO, is the vaccine does not work. And so that's pretty much how you always want to go about identifying that null and alternative. The article is never going to tell you this was the null and this was the alternative. So don't even try to look for it in that sense in the article, because it's not going to be there. You want to glance through the article, see what a scientist was trying to prove. Whatever they were trying to prove, that's the alternative, and then have the opposite of that be the null. Also, another really good way to try to figure out how to identify that null and alternative is look for the words statistically significant in the article. So in this case, right here, and also significant is up here. Now in this case, this article was so short that it really didn't do you much good, because there's only maybe 6 sentences total. But generally, if you had a larger article, maybe say an article that was a full page long, when you find this statistically significant, it will tell you what they were trying to find was statistically significant. So in this case, you could have pulled it straight from the title, HIV vaccine trial was significant. Now once you have the null and the alternative, we need to figure out which one was accepted. What did the article actually prove? So in this case, since the findings were significant, significant means that we had enough evidence against the null that we were able to accept the alternative. So in this case, since the results were significant, we're able to have enough evidence to say that the vaccine works. Now, another way to think of this when trying to determine what the null and the alternative are is, let's say that you are this scientist and you're trying to figure out if this vaccine works. When we go into a hypothesis test, we initially start by always assuming that the null is true. And then we see if we have enough evidence to be able to say that, well, actually the alternative was the true one. And remember that evidence comes in the form of that false positive, right? So if you're a scientist and you've developed this vaccine that you're going to give people, do you want to automatically assume that the vaccine works without running this test first? Or would you rather assume that it does not work and see if you have enough evidence showing that it does? And you always want to do the latter. That's why we do that. Because if we just assume that the thing works, then we would go out and give it to everyone. And that makes absolutely no sense. It's better, let's assume that the thing doesn't work, then see if we have enough evidence to show this vaccine really does work before we go out and start giving it to people. So, looking at these questions here just to kind of go over it again, the null in this case is going to be that the vaccine does not work. The alternative is that the vaccine does work. We know that the alternative was accepted because our results are statistically significant. And how did we know that? Because it's statistically significant. Now, one thing that you need to be aware of, especially when you're outside of this course and you're reading news articles and you're starting to read them more critically, one thing that you're going to notice is a lot of times people throw around the word statistically significant and there's really no meaning behind it whatsoever. For example, in one of the Beyond the Number exercises that you had, there was the article about the same-sex coupling in birds. And he used the terms significant in there, and you were asked what two things were being compared. Well, in fact, there was no comparison. He had used that term incorrectly. He should have never used the term statistically significant or significant because he hadn't done any kind of comparison. There was no study done, so that was used incorrectly. And we see that a lot in news articles, that they throw around these terms so people read them and they think, oh, well, there was some kind of study done, these results are valid, when in fact nothing of the kind was done. They're just throwing around the language. So that's one thing to be aware of when you're reading news articles. Was something actually being compared? Did they actually do anything statistical here? Or are they just throwing the language around inappropriately? Now the next question that I wanted to look at was on the Working Through Hypothesis work page. Let me kind of clear this out a little bit. Looking through this one, I wanted to just run through how to calculate a false positive value and how to set one of these numeric examples up where you actually run the test yourself. So in this one it says, suppose you manage a factory that makes crayons. As long as the machine makes more than 95% of the product correctly, there's no need to replace them. You're trying to figure out if the machines are working properly. So kind of just as a tie-in to Module 2, because this is very important to know the difference between the population and the parameter, we need to recognize that the population in this case is all of the crowns in the factory, and then the parameter is going to be the percentage of those crowns that are working properly. And notice here we don't know the exact number for that parameter, but what the hypothesis test does is it lets me try to figure out, hey, is that parameter above 95%? In which case I'm okay. The machines are making enough of my product properly. Or is that parameter somewhere below 95%, in which case I'm going to need to go and fix the machines in the factory. So the first thing you need to do is set up your hypothesis test. We have the null and we have the alternative. So what we're going to do in this case is we want to set the alternative is that the machines are working properly. In other words, P, which represents the parameter, that parameter is over 95%. Because just like with the vaccine, we don't want to start assuming that the vaccine works. We want to assume that it doesn't work. So in this case, what we're going to do is we're going to set the null to be that the machines are not working, meaning that the parameter is somewhere at or below 95%, and the alternative is going to be that parameter is above 95%. The machines are working, because we don't want to start out saying the machines are working. Instead, let's say that they're not working and see if we can find enough evidence to show that they are. So once again, in this case, the null here is going to be that P is less than 0.95. The alternative is that P is greater than 0.95. And another thing that I think confuses people is when doing hypothesis testing, we use the letter P a lot. And you have to be very careful because there is a difference between P, P naught, P hat, and the P value. Those are four completely separate things. So in this case, when we're setting up and we just have a P all by itself, that P represents parameters, what that stands for, and we use that in the hypothesis test stating what the test is. And that's one thing in one of the worksheets, and forgive me, I can't remember the title off the top of my head, but the very first thing that was asked to do was to set up the test, state what the test was, and a lot of you did not do that. You have to state the test first, because otherwise what is the point in running the test if we don't know what we're testing first? We always need to state what are we testing. So now in order to make sure the machine's working properly, you're going to take a sample of 50 crown boxes and find that 48 were made correctly. Do the appropriate calculations to determine if you have enough evidence to say that the machine is not working properly. So once again, remember, the null was that the machines were not working properly. We're going to assume that they're broken, so it's P less than 0.95. And we're going to see if based on this sample and the statistic we're going to get from it, do we have enough evidence to say in fact our machines are working correctly. So I'm going to come over here and kind of label what some of the different things are. Now one thing to notice is I'm asking you to run a hypothesis test here, and just like in the other worksheets there's a 5-step process, but I'm not going to explicitly go through step 1, step 2. I'm not going to label those for you. You need to know that when you say run a hypothesis test, there are those 5 steps that you're going to need to go through. In the beginning worksheets I listed them for you just so you could get used to the steps, but by now you should be able to go through all of those independently. So the first thing we need to do is identify some of the things we're going to need here. The first one we're going to need to identify is our P naught. Now, the easiest way to remember where to get P naught from is P naught comes from the hypothesis test. So in this case, our hypothesis test involved 0.95. The null was that P was less than 0.95, and the alternative was that it was larger. So P naught, in this case, is just going to be 0.95. It's that hypothesized value that we're looking at the parameter at. And another easy way to remember this is we've got P naught, we've got that little 0 here. If we come back over here, we've got H naught with that little 0. So just remember that you can generally just pull that number straight from there. Another thing we're going to need is we're going to need P hat. Now, P hat, and if you take a future statistic course, you'll see this, generally when we put a hat on things, that means it's a statistic. In this case, the sample proportion. So we found that out of the 48 out of the 50 crown boxes were made correctly. So P hat is going to be 48 divided by 50, which in this case is equal to 0.96. Another number we're going to need to know is N. N is always and will always be the sample size. We took a sample of 50 crown boxes, so N in this case is 50. Now the next number you're going to need is the standard error, or SE in this case. This is a number you're going to have to calculate. So just as a reminder, the formula for the standard error is equal to the square root of P naught times 1 minus P naught. Oops, that's a P naught. And then we're going to divide that inside of, this is all inside this square root sign, we're going to divide that by the sample. So in this case, this is going to be equal to 0.95. We're going to multiply that by 0.05. And we're going to divide by 50. And when you do that, you should get a standard error of 0.03082. Now once you have the standard error, the next thing you need to calculate is D. D stands for the difference. D is always going to be the difference between p hat and p naught, or the sample proportion and p naught. So D is p hat minus p naught. So in this case, it's going to be 0.96 minus 0.95, and we're going to get 0.01. And then the last thing we're going to have to calculate is our z-score. Now z is going to be equal to the difference, or D, divided by SE. So we've got D divided by SE. And so that's just the 0.01 divided by the 0.0382. And when you do that, you should get 0.32446. And one thing I really recommend while watching this is to follow along in a calculator. Make sure that you know how in your calculator to put in, for example, this square root up here. I know that seems kind of trivial, but every calculator works a little differently, and you need to make sure that you're able to actually do that on yours. Now once we have our z-score, what you'll do is use the table on page 131 to look up what the p-value is. Now notice that table is also called the false positive rate table, and that's because the p-value and the false positive rate are the exact same thing. And when you go and you look that up on the table, you should find a p-value. And notice that we call this p-value. It's not just p, it's the p-value. We find that that number is 0.37. And if you're having trouble, going to the table, looking up this number, and finding the p-value, if you'll go back and look on the announcements, I posted a YouTube clip that I think illustrates pretty nicely how to look up this table and to get these numbers. So we've got our p-value. Now a lot of times when students get down to this p-value, they're like, oh, what do I do now? I've got a p-value. Well, this p-value is our evidence. So we need to go back and figure out what was it that we were trying to prove in the first place, and how much evidence do we have. So if we go back to the question at hand, we were talking about, do 95% of the machines work correctly? So we first assumed that they didn't. So we've got that null of p less than or equal to 0.95, and we have an alternative of p greater than 0.95. Now with a p-value of 0.37, what we're going to do in order to determine if we're going to fail to reject the null, or we're going to reject that null and accept the alternative, what we do is you always compare the p-value to alpha. Now I said in the announcements, if alpha is not given, and in this case, in this case we're given alpha, it's 0.05, but if not given alpha, just assume that's 0.05. So the question is a p-value of 0.37, is that larger or smaller than 0.05? Well, in this particular case, 0.37 is larger than 0.05, so we have that the p-value is greater than alpha, and when p-value is greater than alpha, we fail to reject the null. So in this case, we're going to fail to reject. And it's important, a lot of students get down to this point and they say, okay, my p-value is greater than alpha, I'm going to fail to reject. Well, that's great and that's correct, but we need to remember that it's very important to go back and look at what we were testing. So our null hypothesis in this case was that the machines were not working. So if you fail to reject the idea that the machines are not working, then you probably are going to have to go and replace the machines at the factory. You don't have enough evidence to say that your machines are working properly. So you're probably now going to have to go figure out what machines are not working properly so that you can get production back up working. So that's 2 sample problems that you could see on the exam. And please remember the hypothesis testing is not the only part on the exam. The specificity and sensitivity will also be covered on the exam, anything that we've done in Module 3. Now the last thing that I want to show you and talk about is just some conceptual things that may or may not help clarify, I'm hoping it will help clarify, some of the things that we've been talking about in terms of the p-value being a false positive rate and sensitivity and specificity. So what I have here is a chart that I've made, and so just talking about some different parts of this chart. So looking here at the top, what you're going to notice is we could say that we have specificity running from 0 to 100. On the bottom, I'm going to have false positive rate running from 0 to 100. Because remember that specificity plus false positive rate equal 1, or you can rearrange that in a different position. So as specificity goes up, as specificity goes up, false positive rate has to go down, because they work together in conjunction. Now, how does this relate to hypothesis testing? We talk about how the false positive rate is related to hypothesis testing because it's the same thing as saying, okay, how many times did we reject that alternative when really we shouldn't have? We should have stuck with the null. And that's what our p-value means. So here on the chart, what you can see is we'll look in terms of false positive rate, because remember that's the exact same thing as the p-value. Now somewhere here in the middle, we're going to set an alpha value. Usually set at 5%. I can set it somewhere else, but it's going to be given to you, and if not, we assume that it's 5%. So if that false positive rate, going from 0 to 100, if that false positive rate is less than 5%, or the p-value is less than 5%, you're going to reject the null and say that things are statistically significant. In other words, the likelihood of a false positive accepting the alternative when we shouldn't have is so small that we're comfortable in saying that we're able to reject the null and accept the alternative, because that's the exact, those two things are the same thing. Now notice, if our false positive rate gets larger than that significance level, or that alpha that we've set, this is when we get into the case that the p-value of that false positive, it's greater than 5%, so the likelihood of us rejecting that null when we shouldn't have is getting larger. We're no longer comfortable with that. So that's when we say that we're going to fail to reject that null. It's not statistically significant. I don't have enough evidence to reject that null hypothesis. Another thing to remember here, and this is going to tie all the way back into Module 2. Remember what we're doing here. We're trying to say ultimately something about that population. We're trying to say something about where the parameter falls. Is it above a certain number, or is it below a certain number? What range is that parameter falling in? But since we can never know the true value of the parameter, we're using statistics to run these hypothesis tests and to get an idea of where the parameter may fall. Now, due to sampling variability, that statistic is going to change from sample to sample. So one thing to notice is if your false positive rate, if it falls very close to alpha, so let's say that alpha is equal to 0.05, you get your p-value and it's 0.051. That's very close. One thing to notice is if you were good to go and take another sample, calculate a different statistic, there is a possibility that instead of being in this blue area, you may be on the green. Now, because, hopefully you're taking random samples, your variability isn't going to be huge, so it's not like your, one's going to be over here, and then your next sample, you're going to get a statistic that makes your false positive value over here. It's only the case when you're very close to this mark that you might be able to bounce from side to side. And that's just something to keep in mind for future things if you go into statistics, especially if you start doing research in your field of study. that just because you get a p-value that's 0.051 and you're like, oh, it's not statistically significant, you can almost still say something there, because if you had taken another sample, it could have been right on the other side. So do remember, with sampling, this is all based on sampling, and you do have that sampling variability that we talked about. So when you take another statistic, there is a slight chance that you may have gotten a different result, especially if your p-value is very close to the significance level. So that's really all that I have to say for right now. If you all have any more questions, please feel free to ask me. As I said in the announcement, I am in San Diego right now, so I might not be able to get back immediately, but I am here to help you with anything you need, so just let me know.